So here's our problem. A minus 170 microcoulomb object is placed in a 0.055 newtons per coulomb electric field. What is the force that it feels? So let's start off with our givens. One, we know 170 microcoulombs, that's going to be some charge, is minus 170 microcoulombs. We know the electric field is given, that's capital E, is equal to 0.055 newtons per coulomb. And our unknown, it says what is the force that it feels, so our unknown is going to be force. Before I actually solve the problem, let's sketch out this what's going on here. It says that there's a charge inside of an electric field. It doesn't tell us what's creating the electric field, it just says that there's an electric field. So I'm going to sketch out an electric field. And this is going to be close to a uniform electric field. It is not perfectly uniform, as you can see, but there's my electric field. And there's a charge inside of my electric field. It is a negative charge. As it's a negative charge, we know that positive charges feel a force in the same direction as the electric field. Negative charges are going to feel a force in the opposite direction. So the force is going to have to be in that opposite direction. And that basically shows our entire situation. We have this charge in this arbitrary electric field, feels a force in the opposite direction. There are two possible equations that we might use. One is the electric field created by a point charge. That's K, Q over R squared. The other is the definition of electric field. E field is equal to force over Q. Just from what our givens are, we know that it's going to have to be the second one. And the second one also tells us about the electric field felt by a charge, little q. While the top one is just the electric field created by a point charge. Since we don't know what is creating this electric field, created by a point charge, capital Q. Since we don't know what's creating the electric field, we have to use the bottom one anyway. So that's our equation. Let's solve it. E equals F over Q. And that goes into, well, force is just equal to Q times E. We plug in our numbers, we get F equals negative 170 microcoulombs, negative 170 times 10 to the minus 6 coulombs, times our electric field is 0.055 newtons per coulomb. That gives us a final force of, it's going to be a negative number, and let's check what it is. Minus 170 times 10 to the minus 6, I have to plug it into a calculator, times 0.055 newtons per coulomb gives us negative 9.4 times 10 to the minus 6. Coulombs cancel, we're left with newtons. Now that gives us the magnitude and direction of our electric field. The magnitude is 9.4 times 10 to the minus 6 newtons. And the direction, it says negative. Now we didn't explicitly pick a direction to be positive, but we did implicitly. Electric field and force are both vectors. And when we said that our electric field up here is positive, we implicitly chose the right direction as the positive direction and the left direction as the negative direction. So this negative answer for our force actually tells us that the force is going to be pointing to the left. And again, we could also write this as the force is equal to 9.4 times 10 to the minus 6 newtons, opposite the direction of the E field. Of the E field. And that's that.